In this video, I will show you how to represent a system of equations using a matrix equation, and then we will solve that matrix equation. Now in this video, our matrix equations are going to be 2 by 2 matrices, so they will be easy enough to solve by hand. In the next video, we will have 3 by 3 matrices, and I will show you how to solve those using a graphing calculator. Let's start with number 6. It's very easy to convert this into a matrix equation. The coefficients are 8, 7, 4, and -9. All right, over here on the left hand side. So this will be my coefficient matrix, and I will call it matrix C. The variables are x and y, so I will go ahead and make a 2 by 1 matrix, and I'll just put x and y. This is my variable matrix, so I will call it matrix V. And then we have the answers, these constants over here. So I will write 5 and 65, and I will call this matrix A for answer matrix. So not only are we going to solve this matrix equation, but we are going to solve it without using a graphing calculator. We're going to do it by hand. So here's how it works, guys. As I'm planning ahead, I realize that we're going to need inverses. All right, ultimately we will need the inverse of matrix C. And in order to find the inverse of matrix C, we're going to need first the determinant of matrix C. So because I know what's coming, you're just going to have to trust me for now. But let's go ahead and find the determinant of matrix C, which we will need later. And you find the determinant by doing the down diagonal minus the up diagonal. So the down diagonal, I mean multiplication, this is -72. Minus the up diagonal, which of course is 28. So that means the determinant of matrix C is -100. So we can use that to find the inverse of matrix C, which is what we're going to need in a minute. So let's go ahead and find the inverse of matrix C. The inverse of matrix C starts with the reciprocal of the determinant. So that's why I'm going to put -1/100. All right, it's the reciprocal of this. And you multiply that by a very special matrix that you get by reversing and negating the diagonals of matrix C. You've got to reverse, negate, reverse, negate. When I say reverse, I mean the down diagonal. These numbers must be reversed. So this is going to be -9 here and 8 here. When I say negate the up diagonal, these numbers are not going to move. They're just going to change signs. So this will become -4, and this will become -7. If these had already been negative, they would have become positive. So that's what we have. So we're going to multiply the reciprocal of the determinant times the reverse negate matrix. Now, remember that multiplying by 1/100 is the same thing as dividing by 100. So really we are dividing each of these by -100. So just keep that in mind. So C inverse is going to be, alright, so a negative times a negative is a positive. So all of these negatives will turn positive, and this one positive will turn negative. Other than that, we have 9/100, and we have 7/100. Now here we'll have 4/100, which of course is 1/25, and then we will have -8/100, which is -2/25. Okay, so this is the inverse of matrix C. We will need that in a moment. Okay, so I'm just going to draw a big line here to separate from the rest of my work. So here's the matrix equation that we are starting with. Matrix C times matrix V is equal to matrix A. If we multiply the left side of each equation by the inverse of C, like this, what's going to happen is when you multiply the inverse of a matrix times itself, you're going to get the identity matrix. Alright, so that would give me the identity matrix times matrix V is equal to C inverse times A. When you multiply the identity matrix times a matrix, it doesn't change anything. You're just going to get the same matrix back. So matrix V, the variable matrix, should equal the inverse of C times matrix A. Alright, substituting in the actual matrices, the inverse of matrix C, that's what we just found. Okay, so that's right here. And then matrix A is 565, so that's here. So all I need to do is multiply these two matrices together, and that will give me the answer. Now, when you multiply one matrix times another matrix, you pay attention to the dimensions. So this is a 2 by 2 matrix, and this is a 2 by 1 matrix. Because the inner dimensions are the same, the 2's, I know this is possible. Now the outer dimensions, I'm talking about the 2 and the 1, that tells me that my answer will be a 2 by 1 matrix. And the way I find the 2 by 1 matrix is I'm going to multiply each row times the column. So I'm going to start with row 1. I'm going to write it vertically, but this is still row 1 that I'm about to write down. So row 1 is 9/100ths and 7/100ths. Okay, this is row 1. And I'm going to multiply that by the column, the only column that I have, which is 5 and 65. And then now I'm going to multiply row 2 by that same column. So row 2 is 1/25th and then -2/25. This is row 2. And I'm going to multiply that also by the column 5 and 65. Now, if this is a little confusing, I have entire videos on matrix multiplication. So if you don't know how to multiply two matrices together, you should go back and watch one of those videos first. This will make a little bit more sense. So I'm really assuming that you already know how to multiply matrices, so I'm not going into the gory details of everything I'm doing. But anyway, what I'm going to do is I'm going to multiply these together, and then I'm going to add the result. So 9 times 5 is 45. So I'm going to get 45 1/100ths. Now 65 times 7, I don't know what that is, so I'm going to put that in a 4-function calculator. That is 455 1/100ths. Okay, now I'm going to add these up and see what I get. Alright, this turns out to be 500 1/100ths. Alright, I'm just adding these together. So this, of course, is simply 5. Okay, I'm going to do the same thing down here. If I multiply these together, that's going to give me 5/25ths, which reduces down to 1/5. And then, let's see, I've got -130 25ths, okay, which reduces down to -26 fifths. Okay, so if I add these together, I'm going to get negative 25 fifths, which of course equals negative 5. Okay, so that allows me to say the final answer. Remember, we were multiplying these matrices together in order to find vector v, the variable matrix. And this is what we got. So the variable matrix equals, I'm going to have to squeeze it in here, I'm running out of paper, but the variable matrix equals 5 and negative 5. Which means that x equals 5 and y equals negative 5. So this is the solution. Alright, let's do it again for number 7. I see the coefficients here, so I will build the coefficient matrix 7, 5, 4, and 3. The variables are x and y again, so I will build my variable matrix x and y, and I will set that equal to the answers 14 and 9. So I have 3 matrices here. I will call this matrix C for coefficient matrix, I will call this matrix V for variable matrix, and I will call this matrix A for answer matrix. Now, in order to solve this matrix equation, I'm going to need the inverse of matrix C. In order to do the inverse of matrix C, I'm going to need the determinant of matrix C. So let me start with that. The determinant is down diagonal minus up diagonal. So that's going to be 21 minus 20. So that means the determinant of matrix C is 1. Alright, so now it's time for to write the inverse of matrix C. The inverse of matrix C is always going to be the reciprocal of the determinant, which in this case the reciprocal of 1 is still 1, but then I multiply that by the reverse negate matrix. Reverse negate. When I say reverse negate, I'm going to reverse the down diagonal and negate the up diagonal. Reversing the down diagonal looks like this: 3, 7. Alright, I simply reverse the order of these elements of the diagonal. When I say negate, nothing moves, but I change the signs. If these had already been negative, they would have become positive. So the inverse of matrix C is just going to be this. Normally I would have to multiply by the reciprocal of my determinant, but because I'm just multiplying by 1 in this case, that changes nothing. So the inverse of matrix C is simply 3, negative 5, negative 4, and 7. Now that I have found the inverse of matrix C, I can go ahead and solve this matrix equation. Now what we started out with was the matrix equation C times V is equal to A. Alright, that's what you see right here. Now, if I were to multiply both sides of the equation by the inverse of matrix C, like this, these together make the identity matrix, and multiplying by the identity matrix doesn't change anything. So that means what I really have now is that the variable matrix is going to equal the inverse of C times matrix A. So that's what I'm about to do right now. So that means the variable matrix should equal. Now the inverse of matrix C, that's what we just found: 3, negative 5, negative 4, 7. Whoops, this is positive 3 right now. and then times matrix A, which is this 14 and 9. Okay, so now it's time to multiply these two matrices together. So I'm going to be multiplying these two rows times this column. So I'm going to start with the first row, 3, negative 5. Now, even though it's a row, I'm going to write it vertically. So I'm going to do 3, negative 5. Okay, but this is row 1. And I'm going to multiply that by my column, which is 14, 9. All right, now I'm going to do the second row. So the second row is negative 4, 7. And again, I'm going to write it vertically, even though it is a row. And I will again multiply it by my one and only column, which is 14, 9. So what I need to do is multiply these together and add the result. So if I multiply these together, then I find that 3 times 14 is 42. So I'm getting 42, and then of course negative 45. So if you add that up, I'm going to get negative 3. Okay, now I'm going to do the same thing here. Negative 4 times 14 is negative 56. Alright, of course 7 times 9 is 63. So this is going to be 7. Alright, add those up and you get 7. So that is what you're going to get when you multiply these two matrices together. So that means that the variable matrix is equal to negative 3 and 7. Okay, now remembering that the variable matrix is x and y, that means that x must be negative 3 and y is 7. So this is the solution to number 7. In this video, I will show you how to solve a system of equations like this one using matrices, and we are going to do it by hand. In the next video, I will show you how to use a calculator to solve a system of matrices. Here we'll have a 3 by 3 matrix, so I'll be very glad that we're using a calculator for that one. But this is sufficiently small that we should be able to do this by hand. Let's start by setting up a matrix equation. The first equation will come from the coefficients of these variables. So I will have 3, negative 7, 5, and negative 8. Alright, this is my coefficient matrix. Next comes the variable matrix. You see the variables x and y, so I'll just put x and y in that order as a column matrix. And then I'll make the answer matrix out of these constants over here, 25 and 27. And let's label these. This will be my matrix C for coefficients. This will be matrix V, my variable matrix. And this will be matrix A for the answer matrix. So, before we can solve this matrix equation, I'm thinking ahead, and I know that we are going to need the inverse of matrix C. But in order to find the inverse of matrix C by hand, I will first need the determinant of matrix C. So that's what I'm going to actually find first. Now the determinant of a matrix, well, a 2 by 2 matrix, is the down diagonal minus the up diagonal. So multiplying down diagonal gives me negative 24. And then multiplying up diagonal is going to give me negative 35. Now I said down diagonal minus up diagonal, yet I'm putting a plus sign right here. That's because minus a negative 35 is plus 35. Minus and negative, you add. So that means that the determinant of matrix C is going to be 11. Now, this puts me in a position to find the inverse of matrix C. The first step of finding the inverse is to write the reciprocal of the determinant. So that's going to be 1 over 11. And then you multiply that times the reverse negate matrix. Reverse negate. Now, when I say reverse, I'm talking about reversing the elements of the down diagonal. So I will put the negative 8 here, and I'll put the 3 here. That's what I mean when I say reverse. When I say negate, I'm talking about negating the up diagonal. These will not move, they will simply change signs. So this positive 5 will become a negative 5, this negative 7 will become a positive 7. So reverse, negate. Now, so if I multiply this together, I will have the inverse of matrix C. Now, multiplying by 1 over 11 is really just dividing by 11. Sometimes it's easier to think of it that way. So this will be negative 8 elevenths and 7 elevenths and negative 5 elevenths and 3 elevenths. Alright, this is the inverse of matrix C. Armed with this information, we can go ahead and solve the matrix equation. I'm going to put a line right here just to keep myself organized. So we started out with the following matrix equation. Matrix C times matrix V was equal to matrix A. Alright, that's what we have right here. Now, if we multiply on the left by C inverse, watch what happens. Okay, when you multiply the inverse of a matrix times itself, it becomes something called the identity matrix. Alright, so together these make the identity matrix. And the identity matrix has the property that if you multiply the identity matrix times matrix V, you're just going to have matrix V. So it's kind of like these canceled each other out, but it's because they made the identity matrix. So, in other words, matrix V all by itself should now equal C inverse times matrix A. So this is what we're going to use to do the rest of our calculations. So our variable matrix should equal C inverse, which we just found. Okay, so I'm just going to copy that down. So it was negative 8 elevenths and 7 elevenths and negative 5 elevenths and 3 elevenths. Right? Okay, so that is C inverse. And that's times matrix A, which is this guy. 25 and 27. So if I multiply these together, that should give me the variable matrix that I'm looking for. So how do I multiply these together? Well, I'm going to wind up multiplying these two rows by this column. Let's start with the first row. Okay, focus on row 1. Now, even though this is a row, I'm going to write it vertically. So I've got negative 8 elevenths and 7 elevenths. Okay, this is the first row. And I'm going to multiply that row times the column, which is 25 over, 25 and 27. Okay, before we actually carry that out, let me set up the other one. Now look at the second row. And again, even though this is a row, I'm going to write it vertically. So I've got negative 5 elevenths and I've got 3 elevenths. So this is my second row, which I will also multiply by my one and only column. So the procedure is to multiply and then add the result. Okay, so let's keep these separate a little bit. So if I multiply this, let's see, 8 times 25, I'm using my little 4-function calculator. So what I have is negative 200 elevenths. Okay, 7 times 27, let's see what that is. That's 189 elevenths. Now let's add those together and see what we get. Well, my goodness, that is negative 11 elevenths, which equals negative 1. Okay, so that's going to be the first element of my variable matrix. Okay, now let's find out the second element of my variable matrix. So let's see, 5 times 25 is 125. So here I will have negative 125 elevenths. 3 times 27 is 81. So that's going to be 81 elevenths. Let's add them up and see what we get. Well, that turns out to be negative 44 elevenths, which of course equals negative 4. Alright, so these are the two elements of the variable matrix that we get. Alright, this is the matrix that you get when you multiply C inverse times A. Okay, so our variable matrix V is equal to negative 1, negative 4. Okay, now remembering that our variable matrix V is x and y, that tells us that x is equal to negative 1 and y is equal to negative 4. So this is the solution to number 8. Oh, by the way, if anyone needed us to write this as an ordered pair, we could simply write negative 1 comma negative 4. Alright, that's another way we could write the answer. Alright guys, let's go ahead and do one more example. Again, start by forming your coefficient matrix, which in this case is going to be 4, negative 6, negative 6, and 9. So there's our coefficient matrix. Once again, the variable matrix is going to be x and y. And then we'll set that equal to the answer matrix, 10, negative 15. And let's call this matrix C for coefficient matrix, matrix V for variable matrix, and matrix A for answer matrix. In order to solve this matrix equation, we will need C inverse, the inverse of matrix C. To form the inverse of matrix C, we will need the determinant of matrix C. So let's start with that. The determinant of matrix C is the down diagonal minus the up diagonal. So that's going to be 36 minus 36. Uh-oh. We will have to stop right here in terms of solving this using matrices. Our next step was going to be to find the inverse of matrix C. But if the determinant is 0, there is no inverse of the matrix, so I cannot continue. This means one of two things though. Either there is no solution or there are infinitely many solutions. Let's see if we can quickly try to figure out which one it is. Notice that all three of these numbers are divisible by 2. Let's see what would happen if we divided all of these by 2. That would give us a new equation that was 2x minus 3y is equal to 5. Okay, let me use a different color. Notice that all of these are divisible by 3. Okay, so we could have an equivalent equation that would be negative 2x plus 3y is equal to negative 5. Now, if we were to switch over to the elimination method, we would quickly see that these would cancel out, and the x's and the y's would both cancel out, and we'd have 0. But even the solutions would cancel out. We'd have 0 equals 0. This tells us that there are infinitely many solutions. Alright? If we got a false statement like 0 equals 7, that's when it would be no solution. Hey guys, that's going to do it for this video. Go ahead and click over here to watch the next video, and click over here to subscribe. That way you'll get every new video delivered right to your home screen.